This video is about inverse functions and relations. So when you're working with inverse functions, there's a couple of different things we have to worry about. We have to worry about ordered pairs, which you could also put under the heading of tables. You have to worry about the graphs, and you have to worry about the function or relation itself. So let's say that we are working with the function f of x equals 2x minus 1. And let's start with the table for that. So looking at the table, when we make a table, we can pick any x value we want. So let's say we have 0, 1, 2, 3. And then we have to find the y values. The way we find the y values is by plugging them into the function itself. So we know our function was 2x minus 1. I'd plug in 0 where I see x, and then I'd simplify. 2 times 0 is 0, minus 1 is negative 1. Then we do it again. 2 times 1 is 2, 2 minus 1 is 1. 2 times 2 is 4, 4 minus 1 is 3. And then last one, 2 times 3 minus 1. Sorry, I did not mean to put a divide line there. Is 6 minus 1 or 5. So now we have our table. This table is also a whole bunch of ordered pairs. We could write this as 0, comma, negative 1, 1, comma, 1, 2, comma, 3, 3, comma, 5. So when we have these ordered pairs or this table, the x values are part of the domain. The y values are part of the range. Well, when you go to find the inverse using ordered pairs or using a table, all you do is flip the domain and the range. The inverse, we'd flip the numbers. The domain was 0, 1, 2, 3. That's going to be the range on our inverse. It's going to be the y values. The y values, or the range, was negative 1, 1, 3, 5. That is going to be the domain, or the x values, on the inverse. We can also change our coordinates. Coordinates, we would just flip each one individually. Negative 1, 0. 1, 1, when you flip it, stays 1, 1. 2, 3, when you flip it, is 3, comma 2. 3, comma 5, when you flip it, is 5, comma 3. So that would be the inverse using just a table or some coordinates. The second thing we had to worry about was the graph. When we look at the graph, I'm going to go ahead and plot some of these points that we found on the table. 0, negative 1 is here. 1, 1 is here. 2, 3 is here. 3, 5, we'd go a little bit higher. I didn't mark a fifth point, but I'll kind of extend my coordinates. So my line would look like this. To find the inverse using a graph, it's still going to be flipping stuff, but we're flipping across a 45-degree line. If we drew a line, pretend that's a little bit straighter than it is. If we drew a straight line at exactly a 45-degree angle, to find the inverse, we're just going to flip it over that 45-degree line. So like this point here, if we flip it across the line, it would end up here. At this point here, if we flip it across, it'd end up there. 1, 1's on the line itself, so it would stay on the line, and then 0, negative 1, if we flip it across, would be there. So then we could draw our inverse line. So looking at a graph, it's always a reflection across that 45-degree line. Finally, if we're going to find our inverse using the actual equation for our function or our relation, we're going to have to do kind of a long process. So first, we use f of x quite often to say the y value, because then when we want to plug stuff in, it's easier to use. But we're going to go ahead and replace it with the letter y just because it's going to be easier for what we want to do. F of x and y are basically the same thing, but sometimes they're better in different situations. In this case, y is better right now. Then we flip the x and the y. So there's a lot of flipping going on with these inverses. So here we flipped. Now we're going to solve for y. To do that, I've got to get rid of the -1, so I'd have to add 1 to both sides. It would give me x plus 1 equals 2y. Then I want to get rid of the 2. The opposite of timesing by 2 is dividing by 2. And we do have to divide everything by 2. So we get x plus 1 over 2 equals y. Most of the time then we write it with the y first. And there is a notation to mean, hey, this is the inverse. If I write f and then a -1x, that's saying this is the inverse of f of x. So then we have to replace it with that new notation. So once we have this, they may write something like this a couple of different ways. You could leave it like this, or you could divide each of them individually by 2, or there's really an invisible 1 in front of the x, so you could write it as 1 over 2 and the x to the side plus 1 over 2. Most often it will look like this, but I wanted to show you all 3 ways just in case. So that helps us actually find our inverse function. Now sometimes when we look at our inverses, one of them, either the original equation or the inverse itself, is not a function, it's called a relation. So let's look at one where that will happen. We have y equals x squared plus 1. And let's go ahead and find the inverse. So again, we flip the x and the y. And then we solve for x. We would need to -1 from both sides. Then to get rid of squared, the opposite is to take the square root. Now when we're working with variables and we take a square root, that means we now end up with plus or minus y. So there's actually 2 things going on there. So our original y equals x squared plus 1, this is a function. But our final, our inverse function, is actually a relation. This is the inverse, but it is a relation. So the difference between a function and a relation is all about comparing the x values to the y values. So if we were to make a table, let's say -2, -1, 0, 1, 2 for our function, and then we were to make a table for our relation, let's go 1, 2, 3. Then that can tell us the difference between a function and a relation. So let's check it out. When we plug it in, we get -2 squared plus 1. -2 squared is 4. 4 plus 1 is 5. -1 squared is 1 plus 1 is 2. 0 squared plus 1 is 0 plus 1, which is just 1. 1 squared plus 1 is 1 plus 1, or 2. And 2 squared plus 1 is 4 plus 1, or 5. Now let's look at our y values, or sorry, our inverse function. So this was the original equation. Now we're looking at the inverse. So if we go plus or minus square root of x minus 1, then plus or minus 1 minus 1 is, we do 1 minus 1, which is 0. Plus or minus square root of 0 is just 0. 0 doesn't have a sign, so we can kind of ignore the plus or minus for now. Second one, plus or minus 2 minus 1, would equal plus or minus square root of 1. Square root of 1 is 1. So we have plus or minus 1. So that means 2 has two options to go with it, a 1 and a negative 1. There's actually two numbers there when we say plus or minus. And that's the big difference between a function and a relation. A function, it always is one x value to one y value, one x value to one y value. They go like that. Here we have one x value to two y values. That's a problem. That makes this a relation, not a function. Graphically, when you look at that, the original function was x squared plus 1. That would be a quadratic that looks like this. We flip it over that 45-degree line, which would turn it sideways like this. To determine if it's a function or a relation, when it's graphically, we would do what's called the vertical line test. If I can put a vertical line anywhere I want on the function, and it only passes through the function once, it is a function. If I put a vertical line anywhere on the picture and it passes through twice, it's a relation. So, if you ever see that plus or minus piece there, it's going to be a relation. It is possible that they might just give you one side of it. So just the top half or just the bottom half, and that would still be considered a function. It's only when it has the plus or the minus that it's not a function. So the last thing they might do with these is ask you about the domain and the range of the inverse. So first we have to be able to identify the domain and the range of this function itself. A really useful tool for identifying that is to use a graphing calculator. So I'm going to go to an online graphing calculator. Maybe. There we go. The one I like is called Desmos. Sorry, I accidentally paused it. I was going to an online graphing calculator, and my favorite one is called Desmos.com. Let me see if I can expand the screen now so that you'll be able to see the entire internet page. So we go to Desmos, we launch the calculator, and we type in the function we want to use. So the function we were looking at was y equals 2 square root of x minus 6 And then I have to go to the right so that I get outside of the square root to do the plus 4. Now right now it doesn't show a great picture, so what we can do is drag our graph around with our mouse. So domain is all the x values of our function. So on our domain, the x value where this graph starts is at 6. The graph starts there and it matches up with the x value of 6. And then it goes to the right of that x value. So our domain is every x value greater than or equal to 6. Range, we're going to pick our y value that matches up. And we have to decide, okay, our graph, it's all everything above that y value. So our range is everything bigger than or equal to 4. So going back to our problem. Maybe going back to our problem. I'll just write on this page instead of going back to the other because it's doing something weird for me. So we said our range, our domain was x greater than 6. Our range was y greater than or equal to 4. If we wanted to talk about the inverses domain and range, again, we just flip it. The domain would be x greater than or equal to 4, and our range would be y greater than or equal to 6. The domain still needs to consist of x's, so that's why we keep the x, but we flip the values that were used in the domain and the range. So when you see a square root, it's going to have a very limited domain and range. If you see like a straight line doesn't really have a start or a stop point, so it's all real numbers. The domain is all real numbers, the range is all real numbers, and if you flipped it, it would still be, for the inverse, all real numbers and all real numbers. But I'd recommend graphing them on this graphing calculator so you can check as to whether it has a starting point or if it just keeps going forever. So the last thing they talk about in this section is composite functions. So if you have two functions that you're looking at, and they want you to find w of v of 7, that tells us to do these things in a certain order. We work our way inside out. So this is saying take 7, plug it into v. So v is 5 times x. We haven't touched w yet, so it's going to still be there. V is 5 times x, but instead of writing x, I'd write 7. So that would become w of 35. Now w, we're going to replace the letter x again, but this time with 35. So 35 plus 2 would give me 37. So again, we work our way inside out. 7 into w, or 7 into v, find a number, that number into w. Well, the reason we look at this is because we want to see what happens when we do a composite function when you're working with inverses. So what if I did q of q inverse of x? Nope, I should put a number there, sorry. Of 4. This says take 4, plug it into q inverse. Q inverse is 2 times x, so 2 times 4. So that would give me 8. Take 8, plug it into q. 1/2 times 8 then would give me 4. So notice our starting number and our ending number was the same. Well, that is the same for all inverses. Q of Q inverse of x is always x. So I could ask you Q of Q inverse of 723. We wouldn't have to go and plug it into our function. We would just say, oh, that's 723. Or I could flip it and say Q inverse of Q of 5107. Well, again, I don't really need the functions for this. I just say, oh, those are opposites. They get rid of each other. I just am left with 5107. So that ends our discussion on inverses.